All right. Good morning. Welcome. Happy Saturday. We are just about ready, sort of. Pop this out. Um. All right. Let's do. What's this? Really need this one. This new LLM. That was from a week or two ago. Gemma, whatever the one they just released. In any case, all right. Let's get to this browser. So welcome. For anyone who's new who doesn't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. I usually stream around this time each week working on stuff related to CircuitPython, sometimes the project itself, sometimes libraries, sometimes infrastructure, sometimes projects, sometimes wild, harebrained ideas of stuff that I just want to make that happens to involve it. And on even less frequency, on even more sort of occasionally completely different stuff outside of CircuitPython. But most of the time we're here, we're working on CircuitPython. If you don't know what that is, you can learn more at circuitpython.org. This is the main website for the project. It is basically a version of Python that runs on tiny computers called microcontrollers. Typically, the way it works, you'll plug this in to your computer, plug one of these with a USB cable into your computer. It shows up like a thumb drive, and then you can edit a Python code file on that thumb drive. When you save it, the microcontroller, if you're using CircuitPython, will interpret and execute the Python code that you save inside of that file. So that is kind of the very high-level idea of what CircuitPython is and how you program devices with it. You can learn more, like I said, circuitpython.org. Huge thanks, as always, to Adafruit. CircuitPython is an open source project that is funded by Adafruit. They pay a team of folks to work on the project and publish the code under permissive open source licenses. So thanks to them for paying myself and other folks to work on CircuitPython. If you would like to help support CircuitPython and all of the other open source work that Adafruit does, they do have stuff outside of CircuitPython as well, Arduino libraries and all kinds of other things. One of the easiest ways to support them is just purchase hardware from their site at adafruit.com. You can get yourself CircuitPython microcontrollers. You can also get yourself doodads, sensors, buttons, beepers, buzzers, lights, speakers, all kinds of things that you can hook up to your microcontroller to build other projects with. In particular today, I do actually have a Max 44009, which is the new project which I'll be using today, although the thing I'm making you could use a different Lux sensor for just as easily. I just happened to be working on the driver for this one, had it on my desk, and so that is what I'm rolling with. So, today, let's see, I'll search up a few things here. I should have probably done this before, but I didn't. Statue that lines up with sun on certain day. So today I have a thing I want to make, which is sort of broadly, it takes inspiration from this kind of thing where you have statues. This one is a memorial statue that lines up with the sun on certain day of the year. At a certain time, the sun will shine through the holes in all of these statues just right, and it will make, in this case, a seal on the ground. I think that this is not the only statue in the world where this happens. The search terms that I've used are mostly coming up with this one, it looks like, but I do believe there's more, and I think it's kind of like a trope that's been repeated in other places as well, in movies and stuff. Like I feel like there's an Indiana Jones thing where the light lines up in the temple or whatever, right? I don't know the exact one there, but this is one of the inspirations where the light lining up sort of reveals this sort of special message or thing at a certain, in this case, time of year, time of day. So this is one inspiration. A sundial is kind of another inspiration, which is a simpler concept, but pretty similar idea. Like the sun shining on it, you know, reveals a certain message at a certain time of day. In this case, the message being revealed is just, you know, the face of the clock, the time of the day that it is, which is nifty. And so I have an idea that's kind of loosely inspired by these things, but with a more sort of digital twist. What I would like to do is I have the light sensor. In my case, I have some neopixels, which we're going to use to set it up, although sort of in the wild, this idea, you would probably do it without the neopixels. So I have the light sensor. I have a knob in my case because I want to use them to control the neopixels. In this case, you know, again, like if you're not using the neopixels, you don't really need the knob. But I have a display, and on the bottom side of the display, I have a Feather RP2040, which in this case actually is running the Zephyr CircuitPython ports. We're going to be testing out some stuff in that as well with this project. But the idea is you have a message. The message is encrypted. And the key that is used is the chat not scrolling. Let's see here. Oh, the chat's scrolling fine. This is just the background I'm seeing in this thing. Right. Okay, yeah. So you have a message. The message is encrypted with a key. The key includes the lux value that we get from the sensor. So what that means is when you want to decrypt it, you also need the lux value from the sensor to match whatever the lux value was when it was encrypted. So we're kind of like encoding the message based on the light level that the sensor reads. And then later on, somebody could come back and reveal the message under the right lighting conditions. So that is sort of generally what I want to build. We have a couple of steps that we need to take before we are really there, which is we need to get the display, we need to get all the hardware basically sort of initialized and working. So let's start there. This is a TFT Feather Wing. I think it's 3.5 inch E2 one, I do believe. Is what it says on the back. Oh. Okay, we're gonna have to redo the circuit a little bit because I totally used D10 for the neopixels. Cannot do, turns out, because that's used by this display. I'm gonna try to sort of carefully as we can turn this over. Change the neopixels from D10 to D. Let's go. So yeah, and now you can see the feather is there and the feather wing we're plugged into. We need to do anything else while we're down here, because I don't super want to be flipping this over back and forth a million times. Avoid it. You can see a nice shot of me there. Okay. To get things back in frame a little bit. That's why I don't want to be messing with stuff too much, is because I kind of got the camera set up to see everything. It'd be a shame to be going all around moving stuff. All right, so one thing is, we'll turn this on. The display does turn instantly to white, which completely overpowers the camera instantly. Can maybe do this and what is this doing? Images. I don't have any images. I don't really want any images. Can I have the simple test? Is this the simple? I mean, it should just not find anything, so it should be fine, I think. No module, right. Okay, perfect. Display is initialized, and as an initialized display, it's mostly black, which makes it not overpower the camera, which is great. It's upside down. I think we can fix that with, is it rotation or orientation? I think it's rotation. We would want 180, imagine. So it's a shame. I got my ability to Windows key left and right to move windows to occupy half the display automatically. But something it used to do is when you did that, it would also pop up this window in the middle here, this little dialogue thing that was like choosing a thing to get paired with it on the other half. And then those two windows would be linked. And so if I would go to PyCharm and then come back to here, both this and the terminal would pop up. This is a thing that it used to do before I accidentally deleted my display manager. And after recovering, it doesn't do that anymore. And I don't know how to get it back. And I also don't know that, I'm sure there's like a term that would help me get it back by searching, but I don't actually know that term. So I need to dig around in the settings at some point. Yep. Yeah, that was a fun story. So the what led to that is the building the Zephyr native sim. It turns out the way it does display uses like SDL2. What's up, by the way, as well, Ty? It's nice to see you today, my friend. Index is out of range. So maybe this did not fail to find stuff. It's actually, nope, this is a different thing. Okay. Oh, nope, images. Wait, 54. Yeah, I think this is failing because of like trying to find images. I don't really care about, truthfully. I think we can maybe go to the library for HX whatever. HX 8357. Eat a fruit. Hopefully it's going to show up. No. Did I say 8357? It's going to be display IO maybe? Nope, there it is. Okay. Hopefully simple test will be no images. Yeah, this is what I want more. I think I can, it's very tiny, but the shape of it makes me think no module display text. Yeah. Just run this again. Probably the only thing it needs. Random extra long time for Circuit to think about stuff, but okay. Oh, bitmap font. Yeah, fair enough. Oh, and ticks, right, is required because the scrolling one is built in. Okay, there we go. I don't know if the camera... Okay, so we lost our rotation for one thing. I don't know if the camera will want to pick it up very well with all the pixels on, but it's sort of the classic simple test Hello World display IO thing with the green border, the purple inside, and then text in the middle. We can get the rotation back, though, because I do want to be able to read it without going upside down. Rotation 180. Let's make sure that works, and then we'll start adding more to that. And I'll get rid of the purple and green for now. I'll keep the label, though. Actually, we can reuse the label. Don't really need bitmap. We don't really need bitmap. I'm sort of the opinion that I like main group a little better than splash, although I did find eventually where the splash thing comes from. So hello world, we do want different color here. Let's just use, it's going to be, I want to be black background, white text, I think. Let's do that. It should get us to hello world. The camera's going to have to autofocus every time because of the white, but yeah, very good. Okay. Next up is the knob, which is a QT rotary, this thing. And we can't just blindly copy the whole thing. Now we already have some code. Copy the parts we need, which is this. Should have a bus already. Should I? No, I probably don't. Yeah, actually I do because, no, I have the SPI bus only. I say maybe I do because the touchscreen example had the bus because the touchscreen is connected on the I2C bus. But I don't care so much about the touchscreen right now. Okay, seesaw thing, configure, input, digital. Oh, because you can press the button as well. That's right, yeah. I'm not going to use that right now, I don't think, but... And then encoder. Okay, and then theoretically encoder, we should be able to, like, do this kind of thing. Negate. Oh, okay, by default it's the other way around, that's fine. So if the position changes, update it, and then let's change the label as well for now. So text area, text, string, position. Okay, we need another library probably. Seesaw. Whatever else it wants. Pixel buff. Interesting. I guess because it can do neopixels. Have auto reload? Yeah, it does. Okay, so we had hello world for a split second and then it went to 0. I change this, it goes up. If I go that way, it goes down. Very good. Rotary encoder activated. Next, neopixels, which are on pin 12 now. I can probably do neopixels from memory at this point. No particular order. Let's say pixels equals neopixel. It's on board D12. It's how many pixels? Okay, maybe I can't. I think it's pin, and then I think it's number of pixels. I have 8, and then I think it's brightness. We can get helped out by this thing. Auto write. I actually do tend to prefer auto write on. Brightness. Yeah, let's just do that for now. So the goal is going to be to change the brightness using the knob. So I kind of just want the pixels always on white, and then have the knob control the brightness. So we actually want position before we get to here. But I'm not going to call it position anymore. I'm going to call it light level or pixel brightness. 0. Pixel brightness we're going to set here. Actually, pixel brightness is going to have to be slightly different than position. So we're going to keep position, but I'm going to actually call it encoder position just so it's slightly more clear what it is. Okay, so this is not how this works. So fill them with white, put the brightness starts on 0. So as we ramp up the brightness, it should ramp up the lights. As we ramp the knob, I mean, as I turn the knob, it should, I want it to ramp the brightness on the lights, the way we're going to do that is here. If it has changed, we are going to do I don't need too much control, honestly. I think what I'm gonna do is we will always start on 0. I think we should at some point we're going to deal with negatives. We're just going to get rid of negatives so that you can't dig a hole into the negatives. But for now, let's not worry about it. So I don't really want like 1%. I want probably like 5% or so per encoder number. But we do need to max, we do need to min so that we don't go above 0. 1, I mean. Pixels.brightness equals min 1.0. I'm kind of out of order here, but that's how it's working in my head for now. The position, encoder position, but I want to multiply it by 5%. Yeah. And we could do max on 0 here as well, but I actually want to handle the 0 a different way. I want to handle the 0 by just not letting encoder position stay below 0. So like here, I'll just say encoder position equals max 0 encoder position so that it can't go negative. And that's before this happens, so stops all the rest of this also, I think. Nope. What do we got? No module NeoPixel. No module NeoPixel right. Yeah. That was silly. Yeah. Okay. So last week I tried to enable that. We didn't get there. And I don't know why, but for some reason I was like, let me just also test this with the Zephyr port, and I think we can't really, unless we were to get NeoPixel right working, and I don't have confidence that I could do that quickly, and I don't just want to spend the stream again trying. I do think it's close for the RP 2040, which is what I'm on, so like it's tempting. To try like one more time and just try to keep the Raspberry Pi implementation with PIO, but I don't know how deep that rabbit hole is. And I know Scott's also worked on the logic analyzer, which he was showing with NeoPixel traffic, which makes me think his head is in the NeoPixel game as well. So I don't want to necessarily go too far on my own without really understanding how he will want to do that. and I don't want to duplicate it if he's already worked on it. So we are just going to pull a little swapty doodle here. We'll feather out, new feather in. Plug it back in. Wash out the camera. So this one's just not on the Zephyr port. Yeah, so the deal is we can't do that in the Zephyr port right now because NeoPixel Write's not implemented. This is just a test, hardware test. I can overwrite this, that's fine, it's in the repo. Actually, I'm gonna keep this one just for now. So this one's on older CircuitPython 929. Should update it. I think it's possible that auto reload is turned off as well. The boot pie. Alright, so there we go. Back to position. Nice. Okay. Obviously that also washes out the camera, but we can still see the screen, which is nice, and is really all we need. So next is the lux sensor. Which is conveniently in the top list here. Get lux sensor separate from seesaw, separate from this stuff. Okay, now, how about instead of putting the position on the display, let's put the reading from the lux sensor. Which I think is .lux, right? Yeah. So we should still be able to control the brightness with the knob. And we're still basically getting feedback from that on the screen. But the feedback is the lux value. So one thing is the display only updates inside of this loop when we change the knob, which we don't want, actually. We want this to change all the time, whether or not the knob has changed. Because we're getting, like, I think we're like a frame behind. We're getting last frame's reading, I'm pretty sure. So ambient is that. We chunk it up by 1, we get that. We go again, we get that. Okay, maybe we do actually want 1% instead of 5%. Probably we do actually want 1% instead of 5%. So we have a little bit more range here. Okay, that's, yeah. It's a little, okay, very good. Some of them aren't changing. I suspect there's float math weirdness going on, and possibly that the brightness, I don't know. Sometimes it's not changing. That's the gist of it. All right, and this doesn't let us go negative. Oh, except it does, because when I turn back now, it's not going. I think... Oh, why would that be? Well, because this is changing. I don't suppose I can just reset that, can I? Why are these offset? What on earth? I don't think this is gonna work. I suspect this is a sort of a read-only kind of thing here. Okay, so interestingly, that does totally actually work, but now the problem is you have to spin left in order to get brighter instead of right. That feels like it should be relevant. It is odd that it's now opposite of what it says. No, okay, still turning left here. Yeah, so the problem is... So we can reset this, which is nice. We can cap it. But we don't want to, actually, because we want it to go negative, as it turns out. So I think if we swap that one, maybe? Change it to min, because then it will choose the large... It will choose the large negative number, small negative number. No, it's still not working. Okay, it's working, but it's... Okay, what if we just absolute value now? We just absolute value now. Why is this? Oh. Okay, hold on. We might still need this, but honestly, I think probably the problem is we need to do that first. Means we might not have needed to swap those two things, actually. No, okay. Right turn makes it brighter. A little bit at a time. And I can't go negative. Yeah, okay, that's exactly what I want. Right turn goes up, left turn goes down, and we get locked at the floor. So that if we keep turning left, we don't have to like dig back out of the hole once we start turning right. Okay. We have the screen, we have the knob, we have the light sensor. We are pretty much ready, I think. I wonder if there is any sense in going for any tighter level of resolution here. This first couple of things did not seem to do anything. Sometimes I'm turning the rotary encoder and it's not changing. So honestly, it looked off until it got to 8, and I think it's still kind of like... Yeah, I think we have kind of exceeded the actual resolution of the neopixels, because we're turning multiple numbers and sometimes it's just chunking. So like from 7 to 8 it goes from off to on, and then it doesn't change again until... Yeah, not every turn is registering. There you go. It doesn't change it again until 12. Yeah, so this knob is going out, I think. Okay. Yeah, so that's not very useful. So let's just keep the resolution there for now. All right, so we get from 440 down to 318. So we have... Oh, down to 293. 93 to 440. Possibly because I moved the sensor. So this is going to be a little bit sensitive to being jostled for now. All right, so right now we're back to about 318 to 440, which is about 120 lux between them. Okay. Very uncreative message, but that's what we'll use for now. And actually, I'll put a new line in it because I don't know if there will be room to display that on the display without. Okay, so we have secret message. We need to encode it. We want to use the one that doesn't need to be 16 bytes. I think there's one that does automatic padding or something. Arbitrary length, CTR. Okay, so we need a key, we need an IV, need an output byte array, we need to initialize the cipher, encrypt into. Okay. Okay, so what we want to do is input is actually secret message. So in the key, I want to include actually the lux value. Maybe we will use the button actually. Ooh, we will use the button. Button held false. What we'll do is we'll use the button to encode. Text is not defined. That's fair. I think I randomly deleted it. It's like, we don't need this. Get it out of here. Is that we might have needed it? I mean, we didn't really need it. Okay, button. We need to update the value so that it doesn't spam. It's the whole point in having the last button value, in fact. It does tell us that it is active false. What? Oh, it doesn't push anymore. There we go. Got stuck down. Okay, yeah, so value is false when it's pressed. We could say if it changes and it's false, then the button was pressed. And we can encrypt the message and print it out for now. And then what we'll do is we'll put the encrypted message in the code, and then we'll have the decryptor in the code as well. Okay. The one thing is this is encrypting right away, which we don't want to do. We don't want to do this until the button is pressed. And we also want to we need to include the lux value that we're encoding in the key somehow. So we have 16 bytes to work with, which is going to be 16 characters. Okay. I think I'm going to give it some range. We don't want to be like on the money. We don't want to require it to be like on the money exactly right. We want to have a little bit of play. Cuz like here I have relatively predictable luxes as I turn the knob. As long as like the sun from the window doesn't change too much, then the value stays pretty constant, but in reality I want it to like actually get decrypted at some point without having to be too exact. So I think one easy way that I can think of to do that is actually define a range. So instead of saying the lux value of 538 is going to get included in the key, instead of that, we could say like 500 to 600 gets included in the key. And then that's 7 characters. If we do 500-600, which is about half our key, if we got into the thousands, then we'd have 9 characters perhaps, which is over half our key. Yeah, let's do it that way for now, and we can kind of dial it in as needed. So I think can you change characters in this? If I have a BS, a byte string that says something, can I say BS1 equals A? No. Okay. Be cooler if it did. Hmm. Trying to decide the route we want to go. So I think I could probably use like, okay, well, one thing is this would have never worked anyway because it was trying to assign a string instead of a byte, but the error makes it clear that that's not the actual problem. Could maybe slice? Could we slice? I don't think we could slice either. Python modify elements in byte string. Not really elements exactly. Characters, I guess. Convert bytes to a byte array and then modify them and then convert it back. That's fair, I guess. Okay, we can't do this actually in this order. We need the key to be here, which means we can't actually create this. Still here. We need to change the key here. So key array equals a byte array of the key. Or byte. I'm actually just going to hard code the key for now. So let's say that we do want 300 to 400, because that's below. Yeah, okay, let's say 300 to 400, which right now correlates to position 3. So what I'm going to do is I'm going to say for byte, for B in the byte string of 300-400. And then we are going to go in here. We're going to go key array. We actually want the indexes also. Index in enumerate. So then the key array index, we change the value to B. So we should end up with the original key, but with the first n characters replaced by this, where n is however long this is. In this case, it's 7, because we have 3, 3, and a hyphen. But if we had like 4-4, then it would be 9. So we keep the back half of the original key, and we replace the front half with the range. And then we reset key to a byte of key array. And then we print this because we want to make sure that it actually worked. And I guess we can do this, but we don't need it really for now, so I don't know. You know, one thing I wanted was for it to print like nonsense when it doesn't decode correctly. But that's actually going to be a surprisingly difficult thing to have, because it's going to decode to bytes that the label can probably not show. Devoted. I do not want followers, thanks. Yeah. Let's try this. So it should print the key at least. We can see if that part's working. Somehow we're also going to need to go from the lux value to the 100 range that surrounds it. Which sounds like a job for Claude, honestly. I probably could do the math. But I don't think I'm gonna. Some kind of divides by n, or get the hundreds place and then add 100 to that, I guess is what you need. Yeah, divide by 100, take the int, that's going to give you the hundreds place, and then you would add 100 to that, I guess. Yeah, maybe we'll do it. We'll see. We don't actually need to go up. We can just press. Cipher's not defined. 94 and a. Could have printed. No, 94 is up here. Can't print cipher mode because we don't have cipher yet. Seems fair. Alright, let's try again. Okay, there we go. Okay. In this case, there happened to be a space right here as well, so it kind of even made a space, but that part is just a coincidence. So we have the tail end of the original key, which was 16-byte key right here. We have replaced the beginning of it with our range. Now I want, I mean, I guess we could take the hex. So we would pretend that this got deleted, right? We wouldn't just leave it here. We would have cipher hex bytes. I'll just call it cipher hex. We need bin ASCII because we need to convert those to... Actually didn't know this worked. Hex. We need to convert that to bytes. Unhexilify. Okay. This should just print gibberish as bytes. Okay. Yeah. What does it print if we decode it, even though it's not Unicode error? Yeah, that's unfortunate. So we could, there's a few ways we could, like, part of the vision I have for the idea of this is that you will see gibberish on the screen when the lighting conditions are not met, and then when the lighting conditions are met, the gibberish turns into the clear text message. And if the conditions then go back to being unmet, you go back to gibberish. But the problem that we have is AES doesn't care about printable characters. Okay, here's what we'll do for now. This is not really the solution I like all the way, but it's what I'm going to do for now. Is we'll put the hex. So what we can do is we can attempt the decryption at the current light level. If it was not the same as the light level when it got encrypted, or if it is not within the range, then it is going to decrypt into gibberish, which will look a lot like this. In that case, we will determine that we got gibberish by trying to decode it. We'll catch this Unicode error, and when we catch that, we'll show the hex data, the hex version of the decoded bytes on the screen. And if we do not get the Unicode error, then we will show the actual decoded version of the text, which will be the clear text, if all goes according to plan. We'll probably put new lines in this somehow as well, too, because this will just go off the screen, I think. But let's worry about that when we get to it. Oh, wait, no. Okay. Yeah, so we would have ran into this afterwards, which is that I... What length of ciphertext bytes, I think. Okay, so this failed. The other thing we could do is, like, effectively, this is sort of part of the key space in a way as well. If you change this value, you'll get different data, different encrypted data. So we could actually keep the entire key here and change only part of this with our range, but it's not necessarily matter too much for my purposes, which are just, like, do this for fun. All right, input is gone now. Yeah. I mean, truthfully, we don't really need this stuff anymore right now because we already have the encrypted data. So we can kind of just comment this out for now. It would be nice to go back and maybe also make it to where you can encrypt a new message, but for now I'm going to just kind of pretend like this is embedded with the ciphertext and it's as an object only meant to decrypt, not encrypt. So we'll comment this out so it's not here anymore. Okay, so now when we want to be able to decrypt, so we don't want to show this anymore. Instead of this, what we want to show is, I'm going to go ahead and actually just function this out. So text equals try decrypt. Def try decrypt. So what this is going to do is we have the ciphertext bytes. We're going to try to decrypt them. This is not how functions work in this language. Actually, now I actually want my cipher too. We're going to need a key, and we're going to need an IV. And we need the IV to be the same, which means actually we could just reuse the IV. And we don't want to call our key because we already have key. So we're going to say decrypt key equals, and this is where we need to get our range. I gotta run to the restroom though, so I'm going to do that in BRB. So we need the current reading, which is sensor.lux. So I'm gonna get the current reading. I'm gonna take it as an int of this, and then we're gonna get the hundreds place equals current reading over 100. Then we are going to say the range. We can't use range actually. Key range. Key lux range is the hundreds place, an F string with the hundreds place, 2 zeros, a Right. So I'm calling it the hundreds place, but that's kind of a misnomer. If this was 1,000, we would divide by here, we would get 10. And it's actually 2 digits. Yeah. So, like, that's true. But I think that's fine for now. The name could probably be better. I don't know. But I think it should still work. So, hundreds place, 2 zeros, dash, hundreds place plus 1, 2 zeros, the rest of the key, which we basically redo this thing. Whoops. Boy, I am so happy that undo exists. Can you imagine if we just lost that because my finger slipped? I don't know what is going on with the spacing in this file. Okay. Why does this not know about key? We need global, but I'm not changing it. So what we would do is we would just, this would be key lux range. We will need bytes instead of characters. Well, okay, this is trying to do a decrypt key. Oh, this is no longer red. Okay, well, I don't know why. Not sure what I did to fix that, but I'll take it. Okay, so then this would be the decrypt key. We got the current lux. We found the range, the 100 lux range that it's inside of. We built the string with the dash in the middle for that. We put that together to make the key that we're going to try to decrypt with. So now we can finally have these. Which we can set up with the decrypt key. Decrypted creates length. We should not use output. We should use length of cipher text bytes. Decrypt into decrypted. We're not going to decrypt the output. We are going to decrypt the bytes that come from well, we have ciphertext bytes. We already have them. Same thing we use the length of. Ciphertext bytes. So decrypt ciphertext bytes into the byte array decrypted. Then decrypted byte string equals bytes decrypted, and then try decrypted string equals byte string decode except Unicode error. So here we're going to say, what is it? Text area dot text equals bin ASCII hexalify the decrypted byte array. Decrypted. So we set the text equal to the hex of what we decrypted, which we know is not correct. In this case, we really only know it because we know we encrypted plain text, like ASCII plain text, but that's fine. Okay, so we set this to that so that we have our gibberish. If the Unicode error does not come, then that means whatever we decrypted to does actually decode to Unicode. Technically, I guess it could still be not the right message. It could still be gibberish, possibly, although I think the chances are quite remote. But in that case, what we would do, we want text area to be equal to the decrypted string. So whatever we decrypted it as. If it's gibberish, it's going to show that on the screen. If it's the real message, then it's going to show that on the screen. And this happens here. I don't know how long this is going to take. So I don't know if it's bad to do it in the tight loop like this, but we're going to find out. Unicode decode error is not defined because this is actually just Unicode error. That's probably a CPython to CircuitPython thing, I'm guessing. Unicode decode error sounds more specific. My assumption is that we might only have the higher level, less specific one to save flash or something. Can't convert string to bytes. 104, try decrypt. Bin ASCII hexalify. This is going to be bytes. This is going to be bytes, which we will need to decode into a string. Is that true? Convert string to bytes. Let's print this so that we know what it is also, if this turns out not to work. It's weird because it says convert string to bytes when I feel like what we really asked it to do was convert bytes to a string, so it feels backwards. 136. Now we failed somewhere else. None type has no find. Okay, this is totally a byte string. I think, right? This is what we decrypted to? Yeah, this is what we decrypted to. Because we used this as the key. $136. Oh, we don't return the string. We don't return the string. So we want to just call try decrypt instead. I mean, I guess we could return the string from here and we could return the string from here. That's fine. We could do that. Could do that. Not going to for now though. Okay. That's going to go crazy. Looks like it's going crazy pretty fast though, so I think probably fine to leave it in the loop. All right, so the data changed. Boom. Yes, that's what I want right there. And if you went too far, get back to gibberish. Okay, I would like it to wrap correctly and not be randomly way over here, which I think we can maybe just do with a text box. So text area, instead of a label, all right, so that takes a font, terminal.io.font. It's almost the same, but it has a height and a width. So width we're gonna say is the display size, but we're scaled by 2. We're gonna say scale, we're gonna say display.width over 2. Height over 2, that does not take a group. It takes a alignment. Align, I don't know. Do center, I guess. It was centered before. Okay, this is what is moving this kind of randomly. Oh, it's actually scaled by 3. I think this should auto wrap. We are still printing this. Ah. Okay. Alright. So one thing, we slowed way down, actually, which is interesting. I'm actually sure entirely why that happened. I guess, I mean, we're refreshing more of the display now. Refreshing the display is slow. Okay, so the next part of our problem is that we are partway off the top of the display, and I don't really want to be. I want to be all the way on the entire display. Okay. Now, let's make it stop doing the flashing thing. I don't like that. So I think we should be able to get rid of that by saying here. So let's say this is hex string. And then let's say if text area. Actually, I thought it did this already, though. I'm not sure this is going to work, actually. Upon thinking about this a bit more, I think that I thought it did this internally. Maybe the text, well, but text box extends bitmap ladle. I don't know if this is going to work. We might need to turn off auto refresh. I don't know why it would be refreshing the text, though. Huh. It basically works, but I do still not like... Wait. No, okay. I was like, wait, is that just the camera? No, it is doing that in real life too. Why is it doing that? Are we actually updating? Print setting text? Are we setting it somewhere else? No? Let's turn this off. Huh. Oh. Wait, this one already had it. What? I'm very confused. Ah. Right. Radio. Yeah, so obviously the problem is we are inside of a text box. Text box does wrapping automatically, so this is getting wrapped to multiple lines with hyphens. But that has a result, obviously, of changing the literal string. So when we compare the wrapped string with the unwrapped string, they do not match. Therefore, we overwrite what is on the display. We need to... we need to either wrap the one that we're comparing or unwrap the other one that we're comparing. I'm thinking, what if we replace hyphens with nothing? Yeah, we replace hyphens with nothing, and we replace new lines with nothing. Would it work then? Yeah, I do think actually the if statements are probably redundant, because I think the label does this internally. Oh, interesting. What is BC? Oh, is that the end of this, I think? This is the end of this. Yeah, I think these... Wait, what? Oh, okay, yeah. Cur text is here. Hex string is here. I guess the upside of this not actually being locked to the other side is I can change this a little bit. Actually, no, I could do that too. It just resized, actually, so not quite an upside. All right, so those are the same now. I think that this if statement actually is... I think it's actually redundant. I think we could even just call this anyway, and it would not flash anymore. No, no, that's not true, because internally it's not going to do that same thing we just did. Right? I fixed it by having it do that, so we do actually need to be explicit. Okay, possibly one could argue that that is borderline a bug in text box. I would argue it is a bug in text box, honestly. It's probably doing, because I think it has this comparison internally. I think it has this, like, does the new text equal the old text? And if so, then don't bother, like, redoing the bitmap and all the work and stuff. I'm pretty sure it does that internally, but it's probably comparing the raw text, not the wrapped text that the text box is producing. And internally for the text box, it should be updated to compare the wrapped version instead of the raw incoming version. And then it would work, I think, how it should, which is that it should not bother redrawing everything if the text has not changed. All right, and then we'll have, I mean, this one, I guess, is less necessary. Well, that's not entirely true. This one, it depends on what the clear text message was. In my case, the clear text message does, it has a new line in it. I don't know. We'll see if it blinks when we do it. I think it should be fine still, but I'm not sure. We can turn off the print spam too, because that's going super fast now. All right, so we can see there we don't make it past 100 on the first level. Oop, there we go. Oh, I accidentally did 2. All right, it's still flashing. Then it goes back to flash. I mean, then it goes back to fast. Yeah, I think, so now the problem is that it's gonna be removing, it's gonna be getting rid of the new line that it should have. Wait, I think there's a simpler solution to this. I think, doesn't text box, it will have like a full text or something. Full text. And use full text. We don't need to do this janky replace stuff. We can say if text area dot full text not equal this, then do that. Full text. Actually, that's all it would need to be updated to internally also. It should just compare to the full text. It's not working. Not working. Full text has all the wrapped stuff in it. Why? Original text. Full text maybe would include stuff that got eclipsed off, because I think if you have too much text and you get an ellipse at the end. Okay. Does original text have a public version, or? No. And that's just getting set to, no, full text is equaling join lines. Okay. We want original text. It is technically... What? Okay, there we go. Back to spam there. Turn it up by 1, it doesn't change because it doesn't actually get past 100. Turn it up by another 1, it does change. Takes a while to refresh the screen, but it shows the new gibberish. We go up again. We get actual decoded message. We have way less spam going on over here when it's on the real message. Go again. And we get back to gibberish. Nice. Okay. Let's turn off some spamming here. We also don't really need this to print because we can see it flash the display. It's really obvious when it's setting the text. Nice. Yeah, each different light level has a different version of gibberish. It is kind of obvious that it's hex. Whoa. Oh, I think I went up 1 and then back down 1 there. Oh, interesting. Huh, we hit a middle ground in there. It was showing a different hex. I think in between those two light values, it actually wound up on a different range. Decoded differently. But, yeah. The end result is when the lux value is correct, the message is decrypted and shown. When the lux value is wrong, you get gibberish. And that was the goal when we set out. We've made it. Cool. Yeah, I would eventually like to, I think, set it up a little better where you can push the button and it can output, like, just try to make the workflow a little bit easier. Maybe we'd have an encryptor one instead. Maybe we'd have a separate one for the encryptor. I don't know. In any case, I'd like to maybe make the workflow a little bit better than have to, like, come in here, uncomment this, and press it, and then copy it into here. So maybe there's a way we could improve that a little bit. I would like to do, but I think not right now. And then obviously, to the extent that this has any use in the real world, which is not really, but in the real world, you would not have, again, the neopixels or the knob, so you'd have to just, like, wait for the right lighting conditions, essentially, or move the sensor into the right lighting conditions, or use a flashlight to cause the right lighting conditions, or whatever. Basically, the lux becomes part of the key, is what I set out for. All right, I think I might just wrap it up there. That's basically what I wanted to do. Kind of a fun little harebrained idea of just, I wonder if I could do this and get it to work, and it turns out I can. Maybe I'll demo it on show and tell sometime or something, just as a fun little thing I made, but that's really all there is to it. So yeah, I think that's going to do it. I will say thanks to everyone for hanging out. Thanks to Tithe in the chats. I hope that y'all have a good rest of your day, good weekend. I will be back on Tuesday for the deep dive at 10 a.m. Central on Tuesday. Haven't talked to Scott, but as far as I know, he's deep diving next week, as far as I know, so I think he'll be around on Friday. I should be back then on Saturday next week as well. So Tuesday the 21st over on the Adafruit channel, and then the 25th back here on my channel are the next couple of streams. Again, as long as deep dive is Scott on Friday. Yeah, so long farewell. Thanks for watching.